The following data represent the weight in grams of a random sample of 50 candies. Determine the sample standard deviation weight. So we have, looks like 5 parts of this question. So we definitely want to put this in StatCrunch. You don't even want to put this into a calculator. You most likely put a number in wrong. So we're going to open the StatCrunch. There's my data. I'll go ahead and put in weight. Okay. Again, optional step. Let's go to Stat, Summary Stat, Column, select weight. The standard deviation is in the summary stats. If there's some other ones that you need, like if you wanted a population standard deviation, that's what this unadjusted standard deviation is. If you wanted a mode, you could put that as well. I don't think it's going to ask for the mode. Let me go and select it just in case. And that way it pops over here. Press compute. Okay, so the standard deviation is, and we always have to pay attention to rounding to 2 decimal places, 0.07. So on the basis of the histogram on the right, comment on the appropriateness of using the empirical rule to make any general statements about the weights in the candies. Okay, just because I know at some point we're going to need to do this, let me show you how to create a histogram on StatCrunch. I'm going to go to Graph, and you guessed it, histogram. Select the weight. We're just going to take all the defaults and press compute. Now this histogram looks a little different than the one they've given us. Why is that? Notice how many bins they have. They have 1, 2, 3, 4, 5, 6 bins. We have about double that. So I can change my bin width if I wanted to. Right here, you know, if I wanted to make my bin width, looks like it's 0.05 over 2, so we can make it maybe 0.05 and see what that looks like. So edit. Okay, a little more like that one, almost exactly like that one, right? So there we go. So this does look relatively normal, mound shape. So the empirical rule looks like it would apply. It could be a slight skewness here, but we want to have a little bit of tolerance for things like that. So we could say it is bell-shaped, so we can apply the empirical rule, and now it's actually applied. Use the empirical rule, or the 68, 95, 99.7 rule, to determine the percentage of candies with weights between 0.7 and 0.98. So I went ahead and just drew this out, took a picture of it, and here it is. So practicing statisticians draw out these curves when they are thinking about these things, and you should too. So we draw this out, and we know that 68% of the data fall within 1 standard deviation of the mean, 95 fall within 2, and in fact, that's what it's looking for, right? It's looking for percentages between 0.7 and 0.98. So we know that 95% of my data, roughly 95, falls within that range. The percent sign's already there, so put 95. Determine the actual percentage of candies that weigh between 0.7 and 0.98. So now we're looking here at the actual data and finding out how many of them. So we just basically count. We have 50 candies here. We're going to count how many fall within this range and then divide by 50. So we got a couple options here. If you already have the histogram, or you can create one real quick, you can click this little button here and go to dividers. And then that'll create dividers, and I just sort of dragged them out to where it was right at 0.7, and then another one that was right at 0.9. It's got to be right at it, 0.98. That's the only pain there. There might be a way to, oh, I can double click it and put it in directly. Good, I don't use that a whole lot. That makes sense. So I can double click this and put in 0.7. Nice. So 100% of the data fall within that range. I mean, our histogram bin here, it just, it's an entire bin, it's an entire width. And so all of them are actually kind of right here. We could have done a dot plot. That helps a little bit because we can see the individual values a little bit better. All right, so all of my data fall here. So these last two guys here, the biggest ones, are at 0.97. Right, so I can highlight that and it shows 0.97. Another way to do it, if you didn't want to use a visual, is you can sort the data. So you can go to Data, Sort, or we're just going to select the column, and we're just going to sort it anyway, really. Whoop. I actually have to select the column. And this allows us here, there's my smallest value, 0.71, so it never gets below 0.7, then look at the biggest one, 0.97. So all the numbers fall between 0.7 and 0.98. Okay, now use the empirical rule to determine the percentage of candies with weights more than 91. Okay, so let's think about this. Empirical rule, it's already drawn out for us. So more than 91 is this area to the right of 0.91, right? More than 91. So we don't have that value exactly right, but we can certainly figure it out. This middle part is 68%. So what does that leave for both tails? Good. 100% minus 68% is 32% for both tails, but we just want this one tail. So divide that by 2, and you get 16%. So there's 16% left in this entire tail. So the answer is 16%. Now determine the actual percentage of candies that weigh more than 0.91. So let's go back into StatCrunch. And let me see if I can use my histogram here. I can double click that first one, and I'm going to put 0.91. And this one we'll just kind of drag it all the way out. So it looks like 18% of those are. Let's see if we can do this manually. And maybe just to be on the safe side, it says more than 0.91. So let's put 0.911 just to make sure. Ooh, looks like I did have a value that was exactly 0.91. There it is right there. So another way to do this, right, is to sort it. We sorted it, and we can count the values that are more than 0.91. We have 1, 2, 3, 4, 5, 6, 7, 8. So I would just count 8 divided by 50 is 0.16, which is 16%. And so that one, the empirical rule got it right on the money. It's usually not that close. We can see here the empirical rule was off a little bit, but still we're in the ballpark. So I hope that helps.